On number 2, we're given a system of equations and 3 statements. We have to determine whether those 3 statements are true. So the first statement, the limit as x approaches 3 of f of x exists. In order to show that, you have to show that the 2 one-sided limits are the same. So if we look at the limit as x approaches 3 from the left, that means we're looking at numbers less than 3. So we're going to be using the first line of our function, x plus 2. When we substitute 3 into that function, we get 3 plus 2, which is 5. We look at the limit as x approaches 3 from the right. That means we're looking at x values greater than 3. So we're going to be using 4x minus 7. Plug 3 in. 12 minus 7 is also 5. So because the 2 one-sided limits are equal, that means the regular limit does exist. So this one would be true. The second statement, f is continuous at x equals 3. We need to check to be sure that the y values for each of these pieces is equal at that point. So we need to set x plus 2 equal to 4x minus 7, and then plug in our y value. And again, we get 5 equals 5. So this one is also true. The third statement, f is differentiable at x equals 3. For this one, I would suggest looking at what these graphs are going to look like. Because x plus 2 and 4x minus 7 are both linear, which means they're both just straight lines. If we look at a graph, this first line that's not darkened is the x plus 2. So that's the first part of our graph. The second part of our graph is this darkened line that goes up this way. So where those meet at x equals 3 is a sharp corner. So it looks something similar to this. And functions are not differentiable at sharp corners. So this one would not be true.